Hey guys, Pierre here, Piotr Fissner. Guys, I would like to start showing a bit from diagnosis of general electronics. So this is a 650 about watts power supply for OLED TV. I think over 70-inch LG. Now, you might be wondering why. Our technicians have to start learning diagnosis, and this one is not in the TV, this one is outside of the TV. The customer lives quite a few miles away, so I've decided to not carry that big TV here, just look at the problem. The customer is keen to buy even new power supply, yes. So let's look what we can find here, okay? So first foremost, the ticket is showing no power to the TV. So we can assume two things, okay? One, something is shorted, or two, something is broken but doesn't conduct anymore, okay? So that's what I would look into. Let's take a sip of coffee. The meter, so let's take it in the continuity mode, and let's take the beep. Now we can take the meter, and if you won't see it, you will hear it. So first I would check all the fuses, if anything is blown or not. Not blown. Another fuse. Cool. So the fuses are blown, not blown. Hold on a second. Yes. The fuses are not blown. So in theory, there shouldn't be anything shorted, or could be something shorted in between. Let's check next thing, okay? So on the input side, that's the input side. Of course that wouldn't be. Why it wouldn't be on the input side? Because in that case it would blow the fuses at the customers, or it would blow this fuse, yes, or the varistor, thermistor, or whatever the components are here, yes, because that's the section for the filtering, that's not the section for transforming the power one to another. These are coils, but because they have like a magnetic field adjusted via this plastic here inside, they can be called chokes as well, yes, so it doesn't have to be coil, it could be chokes. For simplicity, let's call them coils. Now, why we've got here on this side two bridge rectifiers? Do you know why? We've got two. In order to understand it, is you would have to learn about full bridge, half bridge, and flyback types of power supplies. So they will have wave, and then one side of the wave here, this side of the wave, is served by this bridge rectifier, and then second bottom is served by this. So in that case, the middle one has to be connected here, and the middle has to be connected here, and the middle is AC. Yes, so now we know that this is more powerful power supply than in most of the TVs, okay? So now, do we have a short in between this? Of course we don't, and it's a diode reading here. And here nothing. And then if we will make it opposite. Okay, so diode is protecting, and here is the diode. Okay, so now here, from the middle to here, nothing. Here, nothing, you see? Now from here, from here to here, the red one is in the middle, and here we've got diode reading. So here we expect the same, and we've got, okay? So now the opposite way. This one in the middle, black one, and here 0.4 and 0, 0. So it's the same what was here, yes, 0.4 and 0, 0. So we know that on the input side we don't expect any shorts. So if no shorts on the input side, what else can we do? Well, we've got here transistors or diodes. Sometimes these are double diodes. So here you got 1, 2, 3, 4, 5, 6, 7, 8 of them to check. And then you've got 2 here, 2 here, so that's 4, so that's 12 in total. And then you've got 4 here, so that's 16. Okay, so because I don't see the problem on this side as such, I assume that it won't be here, or it won't be even here. The problem most likely will be on the secondary side. Okay, that's what I can assume. And here is 1Q, so that's another one to check. So let's check on the capacitors on this side. That's the minus side that has a belt, and this one is positive, no short, and yeah, the beep is working. If one will have no beep, then the rest will have no beep. Most of the time they are in parallel, they are not in series or anything, or on separated lines. So in that case we've got diodes as well, which we could check, but I doubt that will be any shorts on this diode. And any other diode? Yes, 0.5. Why it beeped originally? Because I've charged it the other way around, so that's normal. Okay, so the diodes are fine as well. So in that case, let's turn it around and let's check those transistors or double diodes. So this will beep here, that beeps, but to here doesn't, and the other way around, nothing. So this could be potentially a double diode. Okay, even though it has a break here, so the left side and the right side, not the middle side, but this is separated. If I will see that it's a double diode, I won't. Now it's, yeah, now it's growing. Come on, short yourself. Okay. Yes, and it's grown. So it's looking like some quick diode, maybe Schottky double diode. Yes, here. And here it's connected, you can see that. That's growing, that's nice. So if that is growing, I would expect it to okay, that's fine. Exactly. So we got 0.15, that's fine, and the other way around, growing. Okay, so you see, so that's looking the same behavior, the same type of behavior. I wouldn't expect that these are transistors. Need to short these, and the same 0.15, yes, and then 0.15. So you see these will be connected, so that's why it's beeping, yes, and here it's not, and then the other way around, growing, good, here grows as well. So these are fine, and these, I'm going on a bet that this will be double diode. That's of course connected. Oh, that's of course good, and of course this has to be good. So, and that grows. So this section I would say it's fine, yes, as long as these are not transistors but double diodes, then I'm fine. So without looking at the board, without looking at the symbols, okay, that's MBRF 2060 CT. Okay, so that's double diode in 4 cases. You see, that's how you recognize the components without knowing what they are. Let us switch off the light and let us go to different sections. Okay, that's Q, so that I expect that to be transistor. Q, transistor. So let's check these transistors on this side. Are they shorted or not? Where are you guys? 1 and 2. Okay. Okay, so there's no short on this side. And no short on this side. Okay, so there are no shorts on these two. Now, be quiet. Now we've got 2 here on this side. Same story goes. Okay. And the other way to cable. So now I've got red in my right hand. Okay, 1.8 and 1.9. That's close match. That's open loop and open loop to the second one. So that's open loop and that's open. So okay, I can't say these are shorted. So the secondary side, yes, okay. So the secondary side here doesn't look that it has any shorts. So in that case, all it's left now is to check these. And what if I won't find any shorts? Because I assume there will be no shorts because the bridge rectifiers are not showing any shorts. Then in this case, I will have to plug it in, and that's a job for only professionals who know what they're doing, because you can get killed yourself. Okay, so that's working with power supplies. It's safe when they are out of the mains, but when they are in the mains, they can literally kill. I don't expect any shorts here as well, because the bridge rectifiers are not showing any. So that side is fine, and this side. Okay. Okay. Okay, so it's safe to plug into the mains, but in that case, if you would ever want to do it, guys, and you would have to, let's say, well, if you would want to keep to be safe and not get killed, okay, because if you've got no training, you shouldn't do it anyway. But because there are videos online and they are showing how to diagnose things, it's better to know what I'm doing to not get killed, okay? So I would say the most important thing is that don't have anything lying on the side when you plug in devices in. Now, take non-conductive material underneath this, like this, for instance. I've got big black one here, yes? And don't switch it on, okay? Don't switch it on just like that. When you switching this on, it's better to either have a light bulb in series, or yes, have someone standing and can literally switch off the power, pull the cord when they see that something is happening to you. Yes, so I would say that my experience, I was electrocuted many times in my life. Okay, I'm alive because I was careful enough. Okay, maybe like that. Do I have regrets? Yes, I have regrets. Okay, would I do it again? Probably I would. Let's face it, we're just humans. And did I learn anything from it? Yes, I did. And what I've learned is better have someone especially when you start with those, then just start on your own. Because when you start with electronics which have high power and there is nobody else, nobody will help you. So that will be your last time you are doing it. That's what I'm saying. That can kill you. These capacitors are rated usually 400 to 450 volts. Yes, 150 microfarad, 460 volts. Yes, that's what it is. So you can expect up to 380, 390 volts on them. That's why better safe than sorry, guys. So if you can have someone, if you decided not to listen to me, yes, and you decided to plug it in anyway, in that case, have someone just to look after your shoulder and be able to just literally pull the plug, because that can save your life. Okay, and if you've got especially family who care about you, it would be really shame to get killed. Okay, so that's how I check for shorts, and that's the video, which I wanted to record. First we check input side where the power is plugged in from the mains. Here is a plug. Yes, so first we check here. If we don't see shorts, we check bridge rectifier, usually 1. Yes, here is bigger power, so we check 2. If nothing, yes, we can go to the very end. Here we see diodes because it's written D on them. I didn't know because I didn't look at them, but by the way I measured it, I knew these are diodes. So practice makes master. Yes, and then after that I could go back and check the rest of the MOSFETs. Why MOSFETs are important? Because if MOSFET is shorted, then it won't work. And then any diodes on the way, any fuses on the way were checked as well. Then capacitors, those big ones. And now the next part would be, yes, because that's too long video, we've got 17 minutes video. So the next part would be for me to get a standby voltage, check if this is producing standby voltage, and then look how I can trigger power on. Okay, when I can trigger power on and not get killed, then I can see if it will power on. If this will power on, then that means can it produce maximum power? Because if it can produce power in general, usually it can produce the maximum power. Now that would mean that TV is faulty elsewhere. Excuse me. That would mean that the TV would have to come here for further diagnosis, because that won't be the power supply. Whereas if I will power it on and I will see there's no standby voltage, okay, then I can try and fix no standby. If I will see that the standby is on but I can't switch it on, in that case I can then say, okay, the power supply is faulty, I can try to go to the bottom of it or buy another power supply. But if I will switch it on and I will be able to run a load on it, that's not a fault of the power supply. Okay, most likely that's a fault of the TV. So guys, that's all I wanted to share with you, because that's really important to understand how I do those things. Again, don't do it if you're not professional. Don't do it especially alone if you won't listen to me, yes, and you will still do it. And that's why I've recorded it, because more and more people are taught fixing electronics here, and I want them to understand that it's your life, yes, and it's not worth to lose it. Okay, thank you guys for watching. Hopefully you've got a value out of it. Thank you for watching. Bye bye.